MBA633 video prepared by Professor Ahmed Tata, George Mason University School of Management. Given that statistics is all about extracting patterns from data, in this clip we will have a brief discussion on data, different kinds of data, and introduce some definitions associated with data. So the spreadsheet that you're looking at contains data. Typically, when we hear the word data, the first reaction that comes to mind, it must be numeric, but not all data is numeric or quantitative. So let's look at the spreadsheet here in front of us and introduce certain definitions associated with data, and also have a discussion about measurement issues. Now, if you look at this spreadsheet, you can see that it contains data or measurements about various companies. If you look in column A, you have a whole list of companies. And this is typical with data. When you're doing measurements, you perform measurements on certain individual items or objects. So the objects that are subject to measurement, these are called elements. So in our case, for example, each company is an element. So Hansen Natural Corporation would be an element. Energy West Incorporated would be an element. So in this particular spreadsheet, we have about 25 elements. Okay, and typically the elements are identified by names or numbers. Sometimes you want to anonymize the elements and the names are actually not listed. For example, students could be listed by some anonymous number instead of their names. So in this case, we have, in this particular example, we have 25 elements, and for each element we measure certain properties. So the properties of each element that we measure, these are the variables, and in this case these are represented by the columns. So in this example, for each element, the company we are listing, the exchange on which the stock is traded, the ticker symbol, the market capitalization, which is simply the stock price multiplied by the number of outstanding shares, the gross profit margin for a particular year, the year in which the company was incorporated, the standard industry classification SIC code for the company, and its eco-friendly rating by some eco rating organization. So the properties of any element that we measure, these properties are called variables, and that's a very important decision that one has to make when generating data or collecting data. What are the properties of each element that need to be measured? It's a very important decision, and you can't go, it's usually very costly to go back and change it later on. It depends on the types of analysis that you want to do. Certainly, for example, if you think of a list of citizens, what properties about each citizen would you want to measure? That clearly depends on what analysis you want to do. The properties of an individual that the motor vehicles department would be interested in are quite different from the properties of an individual that the IRS might be interested in. So there's nothing sacred about what variables to measure. It just depends on what analysis you want to do, what is the phenomenon that you're trying to understand. So in this example, we have, let's see, 1, 2, 3, 4, 5, 6, 7 variables. Exchange, ticker symbol, market capitalization, gross profit, year of incorporation, SIC code, and eco rating. So 1, 2, 3, 4, 5, 6, 7 variables. So this is, I might say, is variable 1, this is variable 2, and so forth. So each variable must be given a name, which is usually the column heading in this case. Now, if you look across all the variables for any particular element, so let's take environmental tectonics and take all the values for all 7 variables for this particular element. that entire row is called an observation. So an observation is simply the collection of measurements associated with one particular element, and it's typically a row in the spreadsheet over here. Now this entire collection of observations for all the elements together is what is called a data set. So a data set is simply the total collection of data, all the observations for all the elements. Okay. Now in this simplified example, there are no missing values. In other words, when we have the observations, we have values for every variable, for every element. In practice, that is usually not the case. You don't have the luxury of being able to collect values for every variable, for every element. There are missing values in every realistic data set. People don't respond to all questions on surveys. Some people, sometimes you just don't know, you didn't have enough time to finish the measurements, what have you. There are a variety of reasons. So in terms of definitions, we have introduced four terms. An element, that's the object of measurement. A variable is a property that is being measured about the element. Observation is simply the collection of all measurements for any particular element. And the total collection of observations for all elements is referred to as a data set. So people will sometimes say, oh, I have a student data set, meaning I have measurements on certain properties of students in a particular institution perhaps, or I have a price data set, and so forth. Okay. Now so those are definitions. Let's focus on the variables for just a moment and talk about measurement scales. Measurement scales refer to how certain variables are measured, and all measurement scales are not created equal. As I mentioned at the beginning, when we hear the word data, we tend to just think of numbers, but it's not always the case. Now, if you look at the variable called exchange, this one, and you look at the values for this variable, for example, you see Amex, you see OTC, which is over the counter, and you see NYSE, which is New York Stock Exchange. This variable is an example of a nominal variable. In other words, is being measured on a nominal scale. In other words, the values do not represent any magnitude. They're simply labels. Okay, and the labels could be qualitative. They could be text, like they are in this case, or they could be numerals also, that could represent Amex by 1, OTC by 2, NYSE by 3, and so forth. But basically they are nominal. They're just names. The implication being you cannot do any standard computation with them. You cannot take the logarithm, you cannot take the square root, and so forth. Okay, the same with ticker symbol. You can see it's nominal. The only calculation that you can do with nominal data is count. So how many companies are traded on the Amex, how many are traded OTC, how many are traded NYSE. So pretty much all you can do with nominal data is count, or some variation of count. And then at the other extreme, you have what are called ratio scale data. These are quantitative data. So data can be either qualitative or quantitative. And the quantitative data, just remember that underlying all quantitative data is that it reflects some kind of magnitude, how much, how many. So if you look at market capitalization over here, you can see capitalization in millions of dollars. So it represents a magnitude. The other important thing is that the ratio of any two magnitudes makes sense. So if you have a company whose market capitalization is $23 million, and if you have another company whose market capitalization is $136 million, the ratio of those two numbers makes sense. You could justifiably say that one company has roughly seven times higher market capitalization than the other. So the ratio of values for a ratio scale variable makes sense. It's just you can perform that calculation. It's justifiable. Okay. Now, if you look at the last column, eco rating, you can see that it's also numbers. So some organization is rated 2, some is rated 3, and so forth. But here the ratios don't make sense. This is what's called an example of ordinal data. Okay, ordinal. In other words, the order makes sense, so they're sequenced. So 3 is better than 2, 4 is better than 3, and so forth, but 8 is not twice as good as 4. Okay, so when you have a variable like eco rating, it's what's called an ordinal variable. And again, it implies that certain calculations are okay, certain calculations are not okay with that type of variable. Now, if you look at the variable called year of incorporation, 1960, 1967, 1998, 2001, this is an example of an interval scaled data, which means that differences make sense. So if you think about year 0 in the Western calendar, year 0 is not the beginning of time. It's simply a convenient point at which to start measuring time. So the only thing that makes sense over here for the year of incorporation is differences. So if you have two companies that have a 10-year difference in their year of incorporation, and you have another two that have 20 years, then those differences are significant. But you cannot take the ratio of two dates and say that one organization incorporated twice as long ago as another. So the ratios do not make sense, but intervals do. Fortunately, for a lot of the calculations that you will do, statistical calculations that you will do, the data is ratio scale. So things like taking averages, square roots, and so forth will be perfectly valid. You will also be dealing with nominal data where counting will be fine. So just remember that there are different types of measurement scales, and the implication there is that certain arithmetic manipulations are valid or make sense for certain types of data, but by and large we'll be dealing with ratio scale data, and the numerical calculations that we need to do in order to execute our statistical analysis will be valid for that kind of data.